This will be for the con exercise, equivalent forms of exponential expressions. So I believe for all of these problems, we will be given an original expression, and then we want to see if they are equivalent to each of these three following expressions. Now, in most cases, I think the best approach will be to get the smallest base number. And what do I mean by that? Well, if you have x, if you have a number x, and you raise that to an exponent a, that number x is considered the base number. All right? The base number is the number that the exponent is being applied to. And I think the best way is to convert all of these to the smallest base number. All right, so just, I'm going to erase this, but just looking at the base numbers here, you see an 81, a 27, a 3, a 9, a 27, a 3. The smallest one is a 3. So the best bet in this case is that we're going to use the smallest base number, or 3. All right, so let's take that approach and see what happens. All right, so on the top here, I'm going to write out all of my equivalencies. We said the smallest base number is a 3. All right, and the next one up is a 9. We know that 9 is the same as 3 squared, okay? I'm trying to write these numbers in terms of the smallest number, which is 3. And the next one up is 27. We know that 27 is the same as 3 to the third, okay? That's 3 times 3 times 3. And finally, the largest one is an 81. And that's the same as 9 times 9, which is 3 times 3 times 3 times 3, or 3 to the 4th power. All right, so I'm going to replace the 9, the 27, and the 81 with these 3's here. So let's start on the original. Okay, 81 is the equivalent of 3 to the 4th. So in place of the 81, I am going to write 3 to the 4th. All right, and that exponent, the exponent on the 81 is 0.5t plus 0.25. Recall that when you have something with an exponent raised to another exponent, the exponents just get multiplied. So this is going to be 3, and distributing. 4 times 0.5 is 2, and we still have t. And 4 times 0.25 is just 1, so this is going to be plus 1. All right, so the original is 3 to the power of 2t plus 1. All right, and now we're going to work from there. So I'm going to erase this because I have the original in terms of the smallest base number. All right, let's convert the first one. We said 27 is equivalent to 3 to the third. In place of 27, I am going to write, let me use black ink. I am going to replace 27 with 3 to the third, and that is raised to the power of 0.5t plus 0.25. And that's going to be times 3 to the power of 0.5t plus 0.25. Once again, right here, we are just multiplying the exponents. All right. So keep the 3 and distributing. 3 times 0.5t is going to be 1.5t. Right? Half of 3 is 1.5. And 3 times 0.25 is going to be 0.75. All right, use your calculator if you need to. And that's times 3 to to the power of 0.5t plus 0.25. Okay, I'm just recopying. And the 3's match. So we can keep the 3, and then we are just adding the exponents. Recall, if you have x to the a times x to the b, it's going to be x to the a plus b. You're just adding the exponents. So we have, these are all added. 1.5t plus 0.5t is 2t. And 0.75 plus 0.25 is positive 1. So that is the first one. And it matches the original. So the first one is equivalent. All right, the first one is equivalent. Next up, let's convert this. We have a 9. We said 9 is equivalent to 3 squared. And that is raised to the power of t. And that's going to be times 3. All right, if it helps you, 3 is the same as 3 to the first power. Multiplying exponents, 3 squared to the power of t is going to be 3 to the power of 2 times t. All right, I just multiplied these exponents. Times 3 to the first. The 3's match, the base numbers match, and we are just adding the exponents here. When the base numbers match and you're multiplied, you just add the exponents, 2t plus 1. Does it match the original? Yes. So part 2 is also equivalent. Last one up. Replace 27 with 3 to the third. And 3 to the third is raised to the power of t plus 0.5. And that's divided by 3 to the power of t plus 0.5. All right, so we have the 3. And this is something with an exponent raised to another exponent. You multiply. 3 times t. And 3 times 0.5 is going to give us 1.5. Right? Half of 3 is 1.5. And that's divided by 3 to the t plus 0.5. Now, recall when you divide with the same base, the exponents just get subtracted going down. All right, we're just subtracting these exponents going down. I'm going to do this separately. We have 3t plus 1.5. And that's going to be minus the quantity of t plus 0.5. 3t minus t is 2t, and 1.5 minus 0.5 is positive 1. So this is going to equal 3, which we kept, to the power of 2t plus 1. And you can see that also equals the original. So even part 3 is still equivalent. All right, so all 3. Okay, look at the base numbers. We have 64, 4, 16, and 4. We can see the smallest one is a 4. So how about 16? Well, 16 is the same as 4 times 4, which is 4 squared. And how about 64? 64 is the same as 4 times 4 times 4, or 4 to the third. All right, so let's convert the original one. I am going to replace 64 with 4 to the third. And that's raised to the power of 0.5 m. And that's divided by 4 to the power of 0.5 m. All right, multiplying exponents, we have the 4. 3 times 0.5 m is 1.5 m. That's divided by 4 to the 0.5 m. And we have the 4's that match. Subtracting the exponents going down, 1.5 minus 0.5 is just 1. And we still have the m. So it's 1m or just m on the exponent. Okay? So this is going to be the original. And we want to make the other ones match. So let's see, 16 by itself, we said that's the equivalent of 4 squared. Does 4 squared equal 4 to the m? No. So that one's not equivalent. Second one, 16. We're going to replace the 16 with 4 squared. And that's raised to the power of 0.5m. Keeping the 4, multiply exponents. 2 times 0.5m is 1m, or just m. So that one matches the original. And the second one is going to be equivalent. And the third one already is 4m, so we can see that one matches without doing anything. All right, so that's it. All right, last one. Check the base numbers. Here we have a 10, 10, 1,000. So we can convert all of these to the smallest one, which is 10. The only other one other than 10 is 1,000. All right, we know that 1,000 is equivalent to 10 to the third. All right, so let's see. Anyhow, we're going to match either this one here or this one here. All right, either of those. Let's look at the first one. We have 10t squared, 10 to the power of t squared plus 2t. And if we convert the 1,000, the equivalent is 10 to the third. All right, the 10s match. And then we just subtract exponents. T squared plus 2t minus 3. T squared plus 2t minus 3. Remember, you just subtract the exponents going down. And that matches the original. So part 1 is good. Let's move on. This is great. We have all 10s that match. On the numerator, 10 times 10, we keep the 10. Since they're both 10, you just add the exponents, t squared plus 2t. And that's divided by 10 to the third. Again, the 10s match. And just subtract the exponents going down. T squared plus 2t minus 3. That matches the original. Finally, the last one. We have a 10, and we have an exponent raised to another exponent. If we just multiply t plus 3 times t minus 1, all right, we're multiplying the exponents because that's what you do here. FOIL, t times t is t squared. The inner term is 3t. The outer term is negative t, so that's plus 2t. And the last term is 3 times negative 1, which is negative 3. And we can see that matches. And it didn't matter anyway because we already factored this, and we knew that one matched as well. So on these exponents, I just multiplied t plus 3 times t minus 1. Okay, you can use FOIL or distributive property, and you'll get this right here. It matches the original. So all three of them are equivalent.